Welcome to this video where we are going to dive into prime subtraction operation. So we receive as input an array of integer and we are supposed to perform a couple number of operation many times. And in one operation, what you can do is that you can pick an index that you haven't picked before. What does that mean? That means applying the operation on one element, you cannot do it twice. Okay, so once you take the element, the operation consists of taking the prime which is strictly less than that element, the value of that element, and subtract the prime from the element. Once that has been done, we need to check, is it possible to have an array which is strictly increasing or not? If it's possible, you return a true, otherwise you return a false. So that's the problem about. Now let us take this example. It can be shown that this array can be transformed into this following the previous operation we just mentioned. And we all see that this is strictly increasing. You have 1, 2, 6, and 10. So since this is strictly increasing, we return it true. Now let us take this array. This one is false because no matter what you would do here, you will not be able to have an array strictly increasing. So the bottleneck of such algorithm is to find out what would be my approach of solving this. So this will be my approach. How will I solve this? For each of the element, what I will check is that since I want a prime which is strictly smaller than the element, I will first check what is the prime that I can have, what is the biggest prime that I can have which is strictly less than this. I'm taking the biggest prime because taking the biggest prime will lead me to the smallest possible element. And if this one is smallest possible, it kind of indicate me that if this one cannot be bigger than this, whereas this one is the smallest possible, then no one will be bigger than this and the array will not be able to be increasing. So that's my logic. So let's go. So for this one, I'll explain this transformation after. So for this one, I'm taking what is the biggest prime smaller than this is actually 3. So I will make 4 minus 3, which is 1. So now I'm taking this one again. If I want to take the smallest prime less than this, it's actually 7. But keep in mind that this one is already something that you should keep in mind while moving. That means you don't just want to take the smallest prime here, but you want to take the smallest prime that will give you a result which is greater than this. And if you want the smallest prime giving you a result greater than this, you can just update your target. I mean, instead of searching the smallest prime, instead of searching the biggest prime less than this, you can remove this element from this. That means you can make a 9 minus 1 that will give you this. And then now you are searching the biggest prime less than 8, which is actually 7. And then you make now 9 minus 7, which is a 2. We apply the same here. We are 6. We want the biggest prime less than 6, but not just less than 6, but we want to make sure that the result will be greater than this. So we remove this from here, which will give us 4. So we are not searching the biggest prime less than 4, which is 3. So we make 6 minus 3, which is this one. The same here. We can see that we have this, which is strictly increasing. So it's a yes. If you apply the same operation here, we can see that what we have is this. And having this is actually not strictly increasing. So we return a false. This one is also important to go through. Let us go through. We have 5. There is no 1 before, so we don't need to make a special transformation. That's why we have 5 here. So now we are searching for the first prime less than 5, which is 3. So we make 5 minus 3, 2. Here we have 8. Since we want this one to be greater than this, we remove this one from here. So we have now 6. The first prime, like the biggest prime less than 6, is actually 5. 5 minus 8, which is 3. We apply the same here. We want it to be greater, so we remove here. We have 0. There is no prime actually which is bigger than there is no prime which is less than 0, so there's nothing to do. If there's nothing to do, it doesn't mean that there's no solution. It just means that here what you have is 3 minus 0 because there's nothing you can find to remove here. So now that being said, for me, the difficult part here will be to find out what is the next prime, what is the biggest prime less than a given element. For me, that will be the tricky part of this problem. Apart from that, the rest is actually easy. So let us dive into the code and find out how we are going to approach this. So for us to approach this, the first thing I will do is that I will build my primes array. So to build my prime array, you can follow the logic that you feel more comfortable with. I'm going to go with this approach. I think it's Eratosthenes scribe, something like that. So I'll just call it primes and I will say numbers that is going to the maximum possible element we can have is 1000. So I'll just have int mx equals to 1000. I will search all of the prime number less than 1000. So all of the number I'll put them into, so I'll just mx 0. So what we'll do is that we're just going to say from int I moving from 2 I less than mx I plus plus. And for each of the element, you don't need to check if the number of I is actually equal to 0. That means it's an element that hasn't been visited. So if it hasn't been visited, we just need prime dot push back of I, and then we just loop from g equal to I, g is less than mx, and g plus equal to I. And here what we need to do is just to say number of I, we take something different from 0. So when we are going to come back here, we are not going to take those elements because there are multiple of the prime that we took. So with this, we're able to build our array of primes. So now the next thing we need to do is to modify the array. What do I mean by modify the array? Modify the array will be applying this. So transform this into this, transform this into this. So for us to modify the array, what we will do is that we are going to loop into the array. And for each of the element, what we are going to do is that we want to loop in the array. So it's num.side. I guess that is the array. Num.side. So for each of the element, you want to find the prime that we were just talking about, right? So initially, you want to make the first transformation, this first transformation. So we are going to call it target. I'm going to say int target is going to take num of I. Initially, the target is num of I. If we are not 0, that means if we are somewhere here, the new target is actually the value minus the previous solution. So to do that is easy. We just need to check if I is different from 0. So from target, we need to remove the previous solution minus equal to num of I minus 1. So by this, we are able to apply this transformation. So this is okay. And the next thing we need to do now is to find this element for each of the target. So I need another one here. I will call it element. I will initialize it at 0 because if I'm not able to find the element, I want it to be 0. So I will just remove 0 from here, which will give me the same value. And to find the element, you can just use a simple for loop. So you can just for int prime in primes, and then in here you just need to check if the prime is actually greater or equal to the target. So we break. Otherwise, we just say the element is going to take the prime. So element is going to take prime. So it is going to continually erase element until we find the first element which is greater or equal to the target. So at the end here, this element will have the biggest prime less than the target. So you can apply now you have this element. Now you can apply the operation num of I minus target, which is actually just saying num of I is actually taking minus element. And this is all we need to have. Now you can directly apply the comparison here. What do I mean by that? That means whenever you're moving, if the element you have is actually not greater than the previous one, you can directly return a false because you know it will never be strictly increasing. How do you do that? So you just need to check if I is different from 0, and the norm of I is actually less or equal to norm of I minus 1, you return false. And if you find yourself out here, you return true. Let us run. Okay, we have an error. Why are you complaining? If I, oh, if I is different from 0, norm of I, yeah, should be good. Okay, we have a wrong answer. We have a G here, so this is G. Sorry, this is G. So we are looping here the element we want to, in fact, the indexes that we want to transform as 1 is the value of this loop, not this one. So let us run again. Yeah, working. Let us submit. Yeah, it's working, performing very well. So is there anything that we can optimize here to make this algorithm better? So I'm just going to go through two optimization. The first optimization I will do is this guy. I'm taking the limit of 1000 because this is the limit here, but you do agree with me that in this array there's no need to go till 1000. Going till 10 is actually enough for us to have this done. So instead of taking this into this limit, I'm going to take the maximum element of the array. How do I do that? So max, I'll just take max element of num.begin and num.end, and this is actually a pointer to the max element, so I'll just put the star here so I have the value. This is the first optimization you can do. Let us see working. Let us submit. Oh wow, nice, 100%. By using the max element here, you are kind of making sure that you are not having more primes that you really need. So this is one thing you can do to optimize. Another thing you can do to optimize will be, yeah, instead of finding like this, you can use binary search to find with lower bound and upper bound. I will not implement that. I will just leave you have a look on this. If you are able to find a way, nice. Otherwise, don't hesitate to ask in the comment. I'll be really happy to interact with you regarding this. See you tomorrow for a new problem. Ciao.